I'm just going to give a couple minutes as I want as many persons as possible to see the poster that is highlighted. So I'll do another 5 minutes. As I said, just to allow as many persons as possible to come. Still had a restful weekend. Let's get started with today's lecture. Now, we have been asked by the university to advise you of the instructor evaluation method for the summer session. And whilst I had indicated this for Networks 1 and asked for your participation, I don't believe we got enough students participating. And so some of the lessons that we would have loved to have learned, or the feedback that would have helped us to make some improvements for the summer session, were obviously not implemented. Notwithstanding, we are making preparations for semester 1, and as such, it is critically important. Whilst the university generally will be continuing with how we have proceeded for the summer session, with the exception, of course, of laboratory sessions, which you will get further information on that. We will speak to just how you'll be able to go about doing your lab sessions, because of course in some instances you definitely will have to come into and use the university facilities, but that's for another time. What I want to encourage, however, is that you complete the survey. I know that based on the flyer that I have posted, you wouldn't be able to access the link. The link which I'm showing here, again, you may not be able to access, you wouldn't be able to access it. However, I have uploaded the link to Schoology. Yes, it will not impact the secrecy of your participation. We really need to get your feedback, and I'm speaking now both as the lecturer for this module, but also as the vice dean for the faculty, because I need this information to seek to provide a better experience for students for semester 1. So please, just take a few minutes out of your time, go to the Schoology, go to Schoology, access the link, and complete the survey. All right. There's another issue I wish to discuss, but I'll do that at the end of this evening's lecture. We should be complete. We should be finished with this lecture in another hour 15 minutes. Don't expect it to be very long today, but I'll deal with some other administrative matters at the end. So let's get started. Any questions? Everybody cool with that? I hope I will have as many of you participating as possible. Okay, so just a quick recap at what we had done last week. You have already written this, but I just want to put it back on the table because it is a very important component of what we're going to be talking about today. So again, the output of any filter, we have been saying this since we started this particular topic, that the output of the filter is dependent on two primary things. One, the individual circuit element. So whether we're dealing with capacitor, inductor, or whatever combination. So the specific elements within the circuit is important. That will determine the output. And of course, the orientation, meaning how we connect them, whether they are in parallel to the input, in series with the input, you name it. So orientation and individual elements. The other thing we want to highlight is that for tuned RLC circuits, we can use them to create our filters. And the key here is that we use these RLC circuits to attenuate, and we have already gone through what that means, to attenuate, key here undesired signal frequencies. So in other words, if I'm interested in getting low frequency output, it means that the tune circuit that I will have in series would attenuate the high frequencies. And the tune circuit that I would have in the parallel would attenuate low frequencies. Or, yeah? So we attenuate undesired frequencies by connecting a high impedance path in series with the signal and a low impedance path in parallel with the signal. So if I want to attenuate, in other words, I want to reduce the level of my high impedance or high frequency signals, then I would connect that in parallel if it's going to give me a low impedance on high frequency. And if I want to have high impedance, yes, I must connect that in series with high frequency. And in doing so, I end up with a low frequency filter. So this is the key word. All right. I suppose the amount of markings, we might lose the word. But anyway, we're attenuating the undesired signal. All right. So these represent the standard configurations for our filters. For the most part, for those, well, you would have done your electronics, and we would have done our filters, whether in physics or electrical. And you would have been familiar with an L-section filter, right? Where, let's say you are converting AC to DC, then of course you would have your capacitor in parallel and your inductor in series. Now, let's use the principle that we just outlined to say why it is that I would have a capacitor in parallel, because that must make sense, eh? And the inductor in series. If I'm going from AC to DC, the unwanted signals will be high frequency. Yes? So these are the undesired frequencies that I have in the input. So what I want would be a low frequency or low pass filter. That's what I'm building. Now the principle we just presented was that we connect a high impedance path in series. Now what I'm trying to attenuate would be the high frequencies. And for higher frequencies, oh man, I don't believe I did that. Anyway, for high frequencies, we know that XL would be high. And for low frequencies, we know that XL would be low. So it means that the high impedance path to the unwanted signal would be in series, which would be in the inductor. On the reverse, however, the unwanted frequency that I want, again, is high. And at high frequencies, I get a low impedance path in parallel. So I therefore have the capacitor in parallel and the inductor in series. Are we clear on that? Any questions on that? All right. Now, if we start with the L-section filter, all right, or the L-type configuration, what we are showing here is just how we move from the L shape to, let's say, the T. So for the T, what we have done is simply to add, or rather to divide Z1 by 2, Z1 by 2. And so that gives me my T section. So I have half of Z1 on one side, half of Z1 on the other side. And I get my T. If I, however, wanted to convert the L section to a pi, then it means that I would insert a half of the parallel, yes, on either side. Okay, so that's how we move from L section to your T or pi section, pi configuration. All right. Now, because we are dealing with L and C, we also have to bear in mind, how is it that I have an inductor? In terms of inductors in series or in parallel, how do I treat with them? How do I treat with capacitors in series or in parallel? And those things will come into play when we are dividing the impedances on either side. All right, so it's not as simple, divide everything by two, right? It changes based on me going from whether it's a capacitor I'm going to divide into the T or it's an inductor. But the equations that we'll be giving would primarily provide us with calculating the values for your L section or your L-type configuration. And it is from your L-type that you then move to your pi or to your T. All right? So, again, as I reiterated with that L-type, the Z1 and Z2 will be dependent on the frequency requirements, whether I want high pass or low pass. And further on, we will look at band pass filters. Now, a filter must provide the impact of managing the frequencies that we want as output. But it must not interfere per se with the overall operation of the circuit. So when I put that filter in, right, like an embedded system, when I insert that filter, what it should be doing is simply managing the frequencies that are moved from one side of the network to the next. All right, that's the purpose of the filter. And for that reason, when we insert it in a circuit, the input and output impedances must match the circuit impedance. Right? Now, we may not have spoken a lot about impedance matching, but if you recall, when we were looking at your iterative impedance, etc., this is where all of that comes into play. And we talk about the surge impedance, and this is the name that you would use in certain aspects of engineering. Won't get into the details there. But in other areas of engineering, we'd refer to it as the characteristic impedance. All right? And so we are able to establish impedance matching on both sides. And so the surge impedance, if you terminate the filter in its surge impedance, then you will not have what we refer to as reflection in the circuit. And when you move on, you'll see the benefits of that. But the key point that we need to make here is that the filter in of itself must just play that role of managing the frequencies that we want from one side of the network to the other, which is being connected by that filter. All right? And just to go back to the first point we made, we said that Z1 and Z2 depend on the frequency requirements. And so if we were looking at a high pass filter, for example, the series element is a capacitor and the shunt element would be an inductor. Because remember, we are attenuating, if we are to get rid of the frequency, the particular frequency, or should I say, to attenuate a particular frequency which I don't want. If I have a high pass, it means that I want low frequencies. And the capacitor would give me a high reactance to low frequency. And if that is the case, then it means that I would put that in series. The inductor would give me high impedance to high frequency, but low impedance to low reactance to low frequency. So I then would put it in parallel. So for a high frequency or a high pass filter, it means that we'd have C in parallel, in series, and L in parallel. For the low pass, of course, it would be the reverse. All right? So do we have what's on screen? Okay. So remember I said earlier that for the filters or the arrangements or configurations that we are showing here, the primary formulae that we'll be looking at is for Z1 and Z2 from your L section. But of course, we can derive the others for your T and your pi filter. So let's see. So these are the formulae that would be used for your configurations. So if you are dealing with an L type, then the inductor, and this is for your low pass filter, your inductor would have a value Z0 over pi FC. And the C value is 1 over pi FC Z0. But we know that for this filter, we'll be having, all right, that. So this is L and that's C. If I'm doing a T type, we have your L1 and L2. So what we would have therefore is that we'd have, because of course in doing the T, it is the inductor that would be split at the top. So we'd still maintain our C, all right? And of course, this would be your L1 and this would be your L2, all right? And if you just look back at the formula for your L type, this is simply L over 2. Okay. And of course, Z0, I mean, we had said it before, but Z0, that would be your characteristic impedance. Okay, do we have this?
1 second, sir.
Excuse me, sir. FC is a circuit frequency?
The cutoff frequency.
Oh, cutoff frequency. Okay.
All right, sir, finish, sir.
Okay. All right. Of course, oh, this is before the low pass. Yes, I know I'm asking you to write them. I mean, obviously, in an exam, I wouldn't be expecting you to remember all of these. So yes, you'll be given. However, I just wanted to solidify in your mind. So I'm asking that you take them down. For your high pass filter, and then you take this note. All right, just let me know when you're through with this, please.
Finish.
Okay, good. All right. All right. So we have these formulae for our low pass, our high pass. Yes. But of course, at the start of this topic, we spoke about our band stop and band pass filters. So we have here, we're dealing with constant K. These formally relate to your constant K filters, which is, of course, what I have given you to do the design for your little project. So for your bandpass filter, for my bandpass, remember now what the convention is. I want a high impedance in series to the frequencies I don't want. All right? So it must attenuate the frequencies I don't want. And that I will put in series. If I attenuate the frequencies I don't want, I must have the low pass to that in parallel. Now, if you think about that, we're saying we have a series resonant in series and the parallel resonant in parallel. If we recall, for your series resonance, the impedance looks like that. Not exactly, but let's do that a little better. All right, so that's your series resonant. That's just it. Is that how it is, by the way? Well, I look like we really just need to record this thing because I'm speaking to myself. Anyway, so this is the output in terms of your series circuit. You have maximum current at the resonant frequency. So you want maximum output. So this is at F0. And then at your cutoff frequencies, you have F1, you have F2, all right? And that would give you your bandwidth. Now that's for series. When you consider parallel resonance, then you'll have that, which means that your current, of course, is a minimum. And that's occurring at F0. Then, of course, you have your F1 and your F2. So because I want to pass these frequencies, yes, it means that I want to block frequencies here and over here. So if I'm blocking these frequencies, it means that the impedance on these would be high. So we'd have high impedance here. Yes. On this side, because the current is high outside of these frequencies, so outside of this range, yes, our current is high. It means that our impedance beyond this point, our impedance is low. So Z is low. So if Z is low, which is what I want to if Z is low at the frequencies I want to attenuate, then I must put it in parallel. For this one, if Z is high for the frequencies I want to attenuate, then I'll put it in series. And that's how the principle comes in. Of course, you also have the option of putting in multiple sections. So you can combine an L with a T and a pi. If you are looking at a broad frequency response range, all right? So you can cascade different filter sections. Okay, next. So this would be my series resonant, which I'm putting in series because it gives me a high impedance to the unwanted signals. And then I have the circuit, which would be the parallel resonant, which will give me a lower impedance to the unwanted frequencies. So I put that in parallel.
Sir, could you repeat that, please?
Series, high impedance, so it's in series. And for the parallel resonant, low impedance, so we put it in parallel. So this is the low impedance to the unwanted frequency. This is high impedance to the unwanted frequency. But again, remember, I said that we start out by looking at the L section. But if I convert, or if I find the equivalent, let me put it that way, the equivalent T section to this L section, it means that I'll have inductor and capacitor on that side, right? So the question is, how do I treat with these two? Right? So I'd have L1 over 2, and I'd have here 2C1.
Sir, wouldn't you have the same over the left hand side too?
Yeah, man. This would all. All right. So again, that will be splitting it. And as I said, we are bearing in mind that how we treat with inductance is in series and capacitors in series. All right. Okay. And of course, if we're looking at the pi, right, so it's that which is in the middle that will change. Right? So we'll have C 2 over 2, and we have 2L2. So this is your L section bandpass. And so the equivalent T section would be as shown. Okay, for the pi section or pi configuration, all right, for the formally associated with the bandpass filter, I remember again, what we are giving you would be the formally initially for your L configuration, and then you would have to make the necessary adjustments for your T and your pi. So for the bandpass, for your bandpass, these are the equations. All right, so we have our formula for our bandpass filter, and of course, um, because of the sort of attenuation that we'll have from both the um, series resonant and the parallel resonant circuits, yes, the output of course, that will be your bandwidth. Okay, for our band stop filter or band reject filter, the reverse is true. At the lower frequencies, yes, at the lower frequencies, remember now, for your parallel resonant, that's your current output. So the current is higher at the lower frequencies. So if the current is higher at the lower frequencies, yes, then the undesired frequencies, which is what you know what, because this is your bandwidth, you know. It's a band reject. Yes. So if this is your bandwidth, then the undesired frequencies would be over here. And the impedance for your parallel resonant frequency would be higher at these frequencies. So the frequency above F2, frequency below F1, you'd have a higher impedance. A low, yeah? Low impedance, yeah. Low impedance, I'm sorry. Because you are getting a higher current, yes. So for that reason, there's greater attenuation for your unwanted. And so here, the lower attenuation for your unwanted. So you put that in parallel. Once you have the L section filter again, you know that if you're doing the T, Alright. So for your T, okay. And so for your pi configuration, okay, so the final set of equations is for your band stop, All right. So based on the orientation of those two resonance circuits, the final output of the filter would mimic that of the parallel resonance circuit. Yes? And for your parallel resonance circuit, the output so again, that would be our bandwidth. Could draw it a little sharper than that, I think. All right, and that's it for today. More importantly, that's it for lectures for networks 2. All right, so let me deal with a couple admin. Any questions regarding today? Any questions? All right, so well, you know what? Let me deal with the register before I. All right, Adams.
Present, sir.
Okay,
Are you hearing me, sir?
Yeah, man, I heard it.
Okay.
All right,
Yes, sir.
Blackwood,
Present, sir.
Brown, Beresford. Brown. Okay. Boso. Campbell.
Present, sir.
Chen.
Here, sir.
Clark.
Yes, sir.
Carsdale. Darby. Davis.
Here, sir.
Donna. Ellis.
Here, sir.
Ferran.
Yes, sir.
Forrester. Grant. Gray. Jeffrey.
Here, sir.
Johnson.
Here, sir.
Mika,
Here, sir.
Lewis,
Here, sir.
Finch,
Present, sir.
Merritt,
Here, sir.
Montague, Merritt,
Here.
Montague,
Here, sir.
Nevers, Phillips, Porter, Ramsey,
Here, sir.
Reddy,
Here, sir. Here, sir.
Thomas, Watson,
Here, sir.
and Wilson. All right. Okay. Just some quick things. There's no easy way around this. I can't beat around the bush. I'm not particularly happy with the grades I saw for the mid-sessional. Some of the reasons I noted, persons in some instances negated the grades they got for some parts by virtue of answering the others incorrectly. So it may be something that I will look at when I review what you have uploaded, just to see where your errors were. So that I will review. However, generally speaking, wasn't too happy with the grades. Now we're at this juncture. We have one session left. But I mean, I think for most of the people that I have taught before, my philosophy on tutorials is that me bringing questions and doing it in class, can be misleading. I've spoken to some of you, and the feedback I get is that you have done every question that is on the platform. I've recommended to some persons that they access questions from the library's question bank. I don't know if they have done so, but that's another resource that you can get questions. So what I'm prepared to do for Wednesday, I'm not going to change and come with a whole host of questions, but I will facilitate questions from students. I will facilitate you sharing your screen or sharing the screen so that others can benefit from seeing what you have done. And then we will seek to, point out any sort of pitfalls that you may have. So that's my offer for Wednesday. As far as tutorial on the last two topics that we have done would be concerned. Friday, you have your third test, and then a week later, you have your final exam. Now, I know I've called it final exam. The university calls it alternative assessment. But, it's important, students, that whatever we do here, because in the end, sometimes we may think that it's benefiting us now, but the worst thing that can happen is that 5 years down the road, when we have persons coming in to look at how we have executed our classes using this medium, we are not interfacing, we are not there over you. I mean, I have no issue. I've never had an issue giving students open book tests because, quite frankly, if you're not fully comfortable with the material, then having an open book test actually makes it a lot more difficult. So whether you have your notes or not is neither here nor there with me. Whether you use the most complex calculator is neither here nor there with me. What I'm interested in is that for this particular module, that you are fully capable in terms of treating with the different topics that we have covered. So come Wednesday, I will create more or less an open forum in which the discussions can be had, live discussions can be had. So you can bring your questions to that session, and we will work with you in trying to understand or applying the appropriate principles in doing it. All right?
One question.
Yeah, go ahead.
In the final exam, I don't know if I can ask. In the final exam, would the operation be the same as the rest of the tests that we have done before?
That was the original intent. And is it that you have a concern with the method?
No, sir, just asking.
Okay. No, I know my question is a genuine one, you know, because I know that persons have expressed challenges with it.
Right. Uploading and all these things.
Yes, sir. I have a question.
Uploading and in terms of the word process. So that's why I asked the same.
Okay. Yeah, that is what is in the module outline. And I haven't changed that. Yes, somebody else had a question.
Yes, sir. I have for the when we upload, sir, you do I have the answer. Like I was here too.
You're cracking up.
You hearing me now, sir?
You're still cracking up. You're going in and out, but I think I got the gist of what you're asking. Whether or not I look at what you upload. Was that the question? Okay, all right. Yeah, man,
yes, sir.
That's the message. Okay. I look at it as far as ensuring that the credibility of ensuring, trying to maintain the credibility of the test. It is to that extent that I look at it. For example, Mr. Darby, you would be aware that the mid-sessional exam, there were actually 3 different exams that you were given. And in what I did to just try and ensure that there is no collusion, I mean, you know, just try and reduce that and ensure that people are actually doing their own work. 3 of the solution on for each student, that each student will see, 3 of those solutions were the solutions to one of each of the 3 papers. So if for paper 1, the answer is 3, for paper 2, the answer is 6, and for paper 3, the answer is 5. Then all 3 papers will have 3, 6, 5. 3, 6, and 5. And then there's a 4th answer. All right? Now, in the event when I'm looking at someone's paper, I see them working a question that was not assigned to them, then we'll know that, you know, there's an issue, and we can do a back tracing on this end to see exactly what transpired. And, you know, we have gone through all of this simply because of some of the issues that occurred during semester 2 networks 1. All right, we didn't make an issue of it, but we know that there were some issues that occurred. I'm not going to make much of a fuss of it. Albeit, we really should have brought it to the attention of the faculty and treated with it in that way. But it is what it is. It's a learning process for us as lecturers also. Because normally I would have given students the exam for them to just do and upload. All right? We're trying this new thing with using the computer to mark. And for that reason, some persons will benefit, it will hurt some. So I'm still contemplating whether or not I should penalize you for wrong answers, but part of the reason for that being there is to completely remove the issue of guessing and of collaborating with your colleagues. That's the only reason that is there. All right? So in the final exam for Networks 1, there were persons who were giving answers for questions that they were not asked. You with me? Which is why we have taken this extra step. But all I want of you as students is to just do your work, you get the answer, you put it in. You're not sure what you have done. If you want, you do it over, you double check, yeah, and move forward. But I really want to remove that element of either guessing or collaborating, but just to present what you have completed on the paper. If you take the risk at guessing and you guess it wrong, if you take that chance, then you just have to deal with the consequence. All right?
If I may say something, sir.
Absolutely.
Yeah, you mentioned that it's a possibility that you might review the papers and go to the papers and see where we are wrong and maybe do some adjustments. I think that is a feasible idea. One of the things that I observed during the exams is that there's a lot of numbers going at equations and numbers. It's just pure numbers. And it is very easy to leave off a minus sign and get the question wrong. Right? Very, very easy to do that. If the paper was being marked, as you said, without a given answer, maybe it would have been easier for many persons. I'm just saying, it's just my own opinion.
No, I agree with you totally, Mr. Clark. I will not dispute that. And that is one of the challenges I do have. I mean, I recognize that, and I recognize that. But at the same time, it is important for you. For example, let me use question number 3, I believe, which was a transients question. Yeah, I believe one of the answers was 0.3636 or something like that, or 6336. And for another paper, it was the negative of that number. Now, the positive value was based on the how the polarities of this source were turned. And then, of course, you get the negative if you turn them the other way. And for me, whilst I understand what you're saying, that it is easy to just select the wrong 0.636, it is important with a topic like that as an engineering student, you are cognizant that polarities and flow have meaning. So I accept, and this may sound conflicting. I accept what you're saying. I accept it, and I agree with you. But at the same time, because of the topic that we are doing, yeah,
Yes.
because of what I am testing, it is of critical importance that you recognize and you don't make those type of errors. If it is, or if it was that when I look back, because I do have the option to look back not only on what you uploaded, but based on your selection, I can look to see whether or not the 0.36 was next to the minus 0.36. Because there's also that other aspect that I have put in where what one student sees as option A may be option D for the next student. Right? So I do randomize the options. But if I go in and I see that you had those two together, one being minus, one being plus, and you select the wrong one, I'll then go back and look to see what you were doing in terms of your analysis. So there is room to make those corrections, and whilst I did not publicize it, I did make several of those corrections on the final exam for Networks 1. All right? So persons may have left the exam and the score that they may have said that they failed. But we did do the review for the final exam, and we would have to do the same for Networks 2. All right?
As you made a scenario a while ago, sir. In the same scenario, what if the student actually on the workout have that minus 0.6363, but then selected the wrong thing, and based on maybe moving too fast, trying to get things done quickly or whatever? Would you make that adjustment as well? Just in the same sense as you look at the other references?
Well, yes, sure. Sure. And we have made those adjustments, as I was saying, with the Networks 1. I mean, these scores are, they're what the computer have generated. I have to ensure, and this is the process of my own validation of the grades. Because what is important is that at the end of the module, the grade reflect the student's ability in Networks 2, and not the student's ability to use a computer. You with me? So we will do the validation. We will do the validation and look at some of these issues. So I thank you for raising the point. All right, so Mr. Darby is saying that sometimes we work it and don't see the answer due to rounding, and rework it trying to get an answer that is there. All right, now, I'm really not sure how to respond to that one, Mr. Darby. The truth is, the questions that I do or the solutions that I provide are usually done to up to 4 or 5 decimal places, because I want to be as accurate as possible. Now, I have said to students, I've said that from Networks 1, when you're doing electrical engineering, right? Try as much as possible to use the engineering notations. So you want to go down to micro, go down to the micro level, go down to the nano level. But this push for those rounding off, I've said it on a number of occasions. And even when I am marking written scripts, students have lost marks because of this rounding issue. because of what we are doing, milli and micro matters, right? They really do matter. So I am not too sure how to respond to the rounding issues, because this is something that I would have stressed on several occasions in Networks 1. Right? And now we are just at the quote unquote senior level doing Networks 2. So some of those issues I do not treat with. Yes, Mr. Watson.
Sir, in regards to a question on the last test, sir, that was I think it was a Tevlin question, sir. Whereas I didn't see it in this solution that you sent out, sir. Was it that question will not be
question
marked?
number 4.
Yes, sir. And I couldn't get one of the answers, sir.
All right. For that Tevlin question, I didn't provide a solution because that question is already in Schoology with its solution. So the solution is already there in Schoology. You got that?
Yes, sir. But I had an issue, sir. I'm not sure if anyone else had it, sir. I couldn't get one of the answers, sir. It wasn't there.
Okay, you mean when I asked you, I believe, for the
energy.
impedance?
Yes, sir. I couldn't get an answer for I think it was for the energy or I think it was the energy.
The energy, okay.
Yes, sir.
All right. Mr. McFarling, you're saying you have the same issue?
Yes, sir. Because due to the fact that...
You sure you had the same issue?
Yes, sir. I couldn't find my energy. None at all.
Oh, so you just guessed it then?
So I didn't really know if you were calculating it with joules per second or kilowatt.
I'm asking if you just guessed it.
No, sir. I worked it out and saw something very close to my answer.
Oh, okay. All right. Because you got it correct. That's why I was asking if you had guessed it.
I worked out something I'm getting.
All right. Well, all right. So, yeah.
And sir,
but going back to what's next, the solution is is already in Schoology. I mean, it's no harm putting it up.
Okay.
Yeah, Mr. McFarland.
Yes, sir. I have a question. Why isn't that you put up SI units on the options?
Well, those are SI units. I mean, just units period, right?
Yes, sir. But to me, it would make me to find the answers a little bit much more faster than scanning through the whole 16 options.
Let me think about that one, Mr. McFarlane. You see, in some instances, with the unit, well, all right. I'll give serious consideration to that one, because if I do that, it means that I will just I would definitely have to cross-check your work, your work with the solution that you have provided. And I say that because in many instances, the unit would basically give you the answer. You with me? Without even calculating it. If I present some of the units in some of those questions, might as well I give, you could just find the answer even without any form of calculation. But I will take your advice on that, which would therefore mean that if we go that route, there would be strict adherence to only accepting answers for which you have completed the work. All right?
Yes, sir.
Sir Johnson.
Yes, sir. The question I'm asking is, will the exam be scheduled by you as a lecturer or the faculty?
It will be scheduled by me.
If
There's a period in which they have given us to submit the grades. I think there are about 2 or so modules being run for you guys this summer.
Yes, sir, but some of us doing outside modules. For example, I'm doing 4 subjects, and one of them is an outside module, and one of them is a general module. So the chances of clashes is looking very high for me.
I think I have the exam scheduled for the Friday, what's that? No. The 6th or something like that. But I have given you that schedule already, right?
Yes,
sir.
Well, just look at what I have given you and determine whether or not you're going to have an issue and advise me quickly. All right, yeah, Friday the 7th. That's when I think we have the exam schedule. Right?
Okay.
So you're just going to look at the other dates that you would have gotten. The other dates that you would have gotten from the other lecturers. And if there is a major issue for a large number of persons, then we can review that. I mean, one of the reasons I have opted to take the exams out of the Saturday Sunday thing, even though the university does not give any considerations for it, I just didn't want to get into the Saturday Sunday worship issues. The university don't recognize it, but I don't want to have to force persons into that position. So it stays at 2:00 August 7th. Yeah, Mr. Darby?
Yes, sir. You hearing me now?
Yeah, man.
Yes, sir. Back to the rounding issue, sir. Sir, for a question, I was working it on the left-hand side, and I got an answer, but it was close to 2 answers that were there. So I put a slight dash on it, and then I worked on the right-hand side to get a more defined answer that was there on the paper. So that's what I'm saying about the rounding, because I'm not sure what. I think my calculator was in the wrong. Yes, sir. I think my calculator was in the wrong mode, so that's why I worked it on the other side. So I was wondering if you took any consideration when you were looking that we were on the right track, because the answer wasn't necessarily there. We didn't select it, and we work it a different way in order to get an answer that was there.
I'm not even sure. To be honest, I'm not sure to respond to that. Because of how I structured the exam, I have to ensure that although I'm setting 3 different papers, yes, I have to ensure that all 3 papers are at the same level. So I can't give one group a more difficult paper than another group. Yes? Because of that, what I do, I make changes within the circuit. So yes, you're going to see, because of that, you're going to see answers that are close. Because I'm pulling it from the 3 papers. Yes? But I do make a concerted effort not to, have, if an answer is 64 millihenries or milliamps, I try not to have another answer there that is 65 or 60, just put a 0.5. I try to have them as distinct as possible. So one may be 64 milli, one may be 69 milli. But again, I go back to the overall principle that, just try and not round off too early. I know sometimes, I don't know if you're saving and penning, but persons just have this tendency to quickly round off. And that will create issues for you. And that's a principle that I have tried teaching from day one. I really don't know how else to respond.
Sir.
Sometimes,
Miss Ellis, after Miss Ellis, that's it for tonight. Yes, Miss Ellis.
Montague, sir.
Oh, all right, hold on. I'm seeing Miss Ellis's hand raised.
Sir.
Yes, Miss Ellis.
Sir, I'm wondering if at the end, after I finish the test on Friday, if it is that, would you propose like an assignment in case in the end you can use it for
Talking about makeup.
for the batch? Yeah.
Is that Miss Lamanja? Come on. We don't talk about makeup even before we see that we have a problem. Listen, we have had three assessments, and we'll have five. There's 5 pieces of assessments, and this is to give you an opportunity. You slip in 1 or 2, you still have enough, to claw your way back. Right? I am not going to beat around the bush. For me to prepare 1 assessment, it takes me, and I'm talking about, it takes me upwards of 25, 30 man hours to do that. It's a tedious process. So I don't want to promise that will happen. As a matter of fact, I could basically say it's not going to happen. But what we will do, as is normally the case, we will receive after the test on Friday, and we get your submission for your filters, the filter assignment. We will then publish the grades. I think I had proposed Tuesday. So when I publish those grades, you can provide your feedback, and we will do the review at that point. So persons can be clear in their mind, what they need to do on Friday. But I don't want to talk about makeup at this time. All right. So finally we had Miss Montague. She was coming in without.
It's okay, sir. Never mind.
All right, students. That's it for tonight. I've already indicated what we will do come Wednesday. So have a good one. Look over the notes. Remember now there are 2 topics that we had completed. We had finished the transfer function, and then we went straight into filters. So if there are issues with either of those, then we will address them on Wednesday. So have a good evening.
Yes, sir. Thank you, sir.
Cool.